Thank you so much. Actually, I'm very happy and very honored. Okay, I have prepared sort of strange talk, so please help me to find my way through the material because I don't know very much the audience, so it might be. And it is a combination of two or three things. One, I would like to spend some time about the motivation of this kind of research I'm going to talk about. That's where the title comes mostly. And part of it I would like to introduce very shortly the European project, as I take this as an occasion maybe to find interesting collaborations or idea or interaction or some kind of resonance of what you do. I have no idea in many cases, so it's an occasion. And then most of the talk will be about some of the first results that we have, which are mostly about modeling games where agents have frames in a way that I will try to define very, very simply. Okay, that's the idea. And the third part, which is the most substantial one, is joint work with Bob Gibbons, a colleague at MIT, and Marco Ricalzi, almost next door in my department. Not B, yeah, but I'm the king of typos, basically. I think I have a world record in typos, it's good to start from the first page, of course. Yeah, sorry, yeah, that's Bob, Robert, whatever you want. Okay, first of all, let me try to give you a sense of what we mean and why we're interested in fog of conflict and fog of war. As you know, there's a very long tradition, especially military and political thinking, about what is called the fog of war, right? Von Clausewitz actually defined it, but I think the most famous example is Bob McNamara's work on the Vietnam War, where basically he made a fantastic work of, McNamara was the Secretary of State during the Vietnam War, so he had pretty much important decision-making role. And looking in retrospect, years after to the war, he tried to reconstruct what happened and sees the war, at least in part, as a long series of missed opportunities of truce and collaboration with Vietnam, driven by the mindset of the decision makers. And the fog of war is really the fact that the war is a complex thing. You see the war through a very limited selective lens, and this in some cases generates conflict, multiplies conflict, creates a sort of escalation of conflict, which is not needed, not necessary, is the result of people's, decision makers' mindsets. That's the idea of the fog of conflict. And it's a quite understandable and intuitive one, maybe, but it's something a little bit different from the typical way we frame decision makers in economics, for example. But there's another, even more fascinating thing to me, which is, let's say, the fog of cooperation. There's a book that I would recommend to anybody, actually, that has been a major motivation in our work, is The Middle Ground. It's a book about what happened around Ontario, basically a couple of centuries ago, between the native Indians and the French. And the basic idea is it's a great historian work that shows that for 2 centuries they really misunderstood each other in a deep way, but it was fantastic. That promoted a lot of interesting things that happened. It's a great book about what White calls creative misunderstanding. What happens when 2 different mindsets meet? You don't understand each other, but you can negotiate in ways to get productive collaboration, even based on deep misunderstanding. And in a way, the work I want to talk about is really trying to reconcile those 2 things, explain when you might get fog of cooperation and fog of conflict, given the same underlying, let's say, real word. And that's the first strong motivation. In a way, this motivation interacted with historical events, in particular the Bataclan massacre, and it turns out that a few nights after the Bataclan massacre, we were in Brussels, myself and a few friends from a former project, and Brussels was just coming out of curfew. It was a terrible situation. It was really a big anguish to be there. And we started thinking, what should we do next time? And we should really start dealing with the problem of where does conflict come from, how do cultural misunderstanding produce conflict, and so on. And it generated the Odysseus project, which is a project on conflict and opinion dynamics in Europe, in the European space. And it has 2, if you want, aspects. One, I will not talk almost at all today, but it might be interesting for some of you. The broader project is really about developing theoretical concepts and computational tools for understanding, in some cases predicting, cultural conflict and opinion dynamics on issues especially like climate change, hate speech, refugees, populism, and so on, which are the main subjects we are dealing with. And a lot of it is done through analyzing large textual sources from the web mostly and other newspaper and so on, And it also should result in a sort of open access platform everybody should be able to use to enter into this kind of debates, understand what's going on, geolocalize the sources of conflict, and so on. That's the broader context. But as a Venetian unit within this, we have a much more limited one, and that's what I want to talk about. It has two parts. One, the European project has a sort of theoretical core, which is to think, how can we rethink interactive decision-making and conflict when agents have different cultural frames? So they meet with different mindsets. If you want, again, fog of conflict, fog of cooperation. So creating conceptual, if you want, tools for understanding both things. And on the other side, a very large case study trying to apply some of these ideas to a sort of digital history case on anti-Semitism in France over 2 centuries. There we can leverage on the fact that there's a very large, basically, corpus that we can create from the Bibliothèque Nationale de France that in a nice competition with Google Books try to digitalize a very large amount of text. So there's an amazing number of text on, from French Revolution to today that enables to reconstruct the vagaries, evolution, and changes in the concepts. And I will refer shortly to that later on, those of you which are interested especially in language and natural language processing would be, of course, wonderful interlocutors for our project. Nevertheless, what I would like to do today is really to focus on this, simply for the reason that's the first thing on which I have results, right? Here we are still building the corpus in a way, so we are in a very early phase, but on this we started working. So if you don't mind, I will take most of my time talking about the first point, right? Although I'm very much open at the end, if you want to go back to the case study. I'm really fond of the case study. I think it's a beautiful one, and talk more about it later. So that's how I would try to proceed. I think that stops my generalities, and I can get into something more concrete. Okay, so how do we talk, why do we talk about frames, and how do we talk about frames? Frames has been used in all kind of ways. There are frame semantics, there are frames in artificial intelligence, frames are incredibly popular in sociology and so on. And of course, it's one of those notions that fluctuates a lot, right? The way we use it is really taken, as we are social scientists after all, as a background from social sciences, in particular from a great classic, which is Goffman, probably. You have dealt one day, or everybody bumps on Goffman sometimes. And the idea, the fundamental idea is that any interactive situation, every human is forced to ask himself or herself, what situation am I? The situations of interaction are infinite, they are very hard to understand, to predict, but any one of us is really, I'm here in the meeting room, and of course I ask myself, which situation is it? Okay, I'm giving a talk, right? And then you can articulate it in many ways. It's very different from a birthday party, of course, right? Although the same people might collect, or for another type of maybe retirement party or whatever it is, right? So the first question is really what a kind of situation is given a very large space of possible situations, right? And that's really the leading question for us. How can you model agents whose first question is, where am I, in some sense? The second important thing is that those frames, the way you try to capture the situation in which you are based on the principle of selection. Frames are selective, in a way, representations of a broader multidimensional reality. And that's the second principle we will try to exploit. So we live very much in something like, as I will try to repeat maybe later, Flatland. You remember the beautiful Flatland novel, maybe the mathematical novel, where you have these people that live in 2 dimensions that cannot understand the 3 dimension, that constrains their life in interesting ways. We all live in Flatland in some sense, right? And that's the second point. Frames are fundamentally selecting and highlighting just a limited number of features of reality. That's the second point we try to capture. The third one is that many frames are cultural. They are not just a result of your experience, they are inherited by education, living with others, and actually social life is made possible by the fact that we share, in many cases, a lot of frames. These are the sort of guiding ideas about frames, and what we try to do is basically to translate them in manageable things, in a manageable notion, when you think about games. So we don't think about frames in a broader sociological sense. We're restricted to the idea that we study interactions as games. Actually, not as games, but really, as we will see, as spaces of games, which is, I think, a different perspective and maybe a more interesting one.
So it's kind of having constraints on your game. So some action that cannot be taken because of your understanding of...
It's constraint on your perception of the game, what you can see in the game, even before what you can do. Actually, I'll get back to that later. We try not to constrain actions, but just your perception of the space of games, right? Yeah. You live in a world where you have all kind of possible interactions that you will see, and you have to understand which type of interaction you have, and you do it by collapsing this large space in a few cells, basically. Yeah, that's something like that. So let me get quickly through the basic idea, and then I will try to show you a little model where this works fundamentally and produces some interesting results. That's all I want to do fundamentally, right? And I will try to go shortly, but if you want, I'm glad to expand some points that is. The first idea is that a frame is a kind of a projection of a larger world. By projection, I really mean projection from larger dimensional spaces into lower dimensional spaces. So the first fundamental idea is that a frame is a filter in a way, and this filter just captures some aspects, some dimensions, right? And this is literally, if you want, also geometrically speaking or topologically speaking, a kind of projection, I think, where fundamentally you try to understand through this projection which attributes co-occur, if you want, right, in determining what is the frame. So the frame, first of all, is a limited number of co-occurring aspects of interaction. As we will see, for example, the same space of games can be actually represented through very different projections. And although we didn't still work very much on that, a fundamental interesting reason to think about projections is that, as you probably know, projections are a very rich kind of operators. They preserve a lot of properties of the broader space. So it's very interesting to ask how much of the original space is preserved through projection, which properties. But that's something we are still working on, so I'll just mention shortly. But if you're interested, that's one of the most interesting parts. Redefining, if you want, the topological idea of games on projections, right? And that's part of the project. And a fundamental question that you want to address is, first, what happens when people have the same frame, but different type of frame? And second, what if agents live literally in different worlds when you live in different flatlands and you meet together? This is the kind of question we would like first to address. That's the first aspect of frame. The second one is categorization. Not only we capture limited dimensions of the world, but in general we tend to categorize those dimensions. So we reduce them to a few discrete, basically, elements. And this is a fundamental aspect of cognition. As you know, most cognition is in a way categorical. There's a huge psychological literature about this fact. And here again, to quote the classic, right, the drive to partition a continuous world appears to be a human universal, though the nature of the categories constructed may vary significantly among groups and cultures. And we will work very much on this idea that different groups have different categorizations as a fundamental idea. There's a huge empirical set of examples of categorization. I don't need probably to mention here. They are probably familiar. You go from the basic categorical perception, for example, of sound, the way you perceive consonants, right, to cognition, categorical knowledge, to memory, long-term memory storage is fundamentally categorical, to language. The lexicon has a lot of categorical aspects, social cognition, and fundamentally a lot of studies on games, also in interaction, show that if you look at how people conceive interaction situations, most of the time they're reduced to a very limited, small number of prototypical interaction situations, which correspond quite strictly to different kind of classical prototypical games, like, for example, a PD or a coordination game or whatever. And again, we will ask ourselves, what about if you change categories, of course, given the same background of a sort of objective world in which you interact? The third idea is the idea of situations. That's the third part. That's the Goffmanian part of it. And what is a situation for us is basically a region of these projected spaces, right? In particular, the idea is that once you categorize those limited number of dimensions, then the combination of those categories produce a situation. And I will give you a very precise example of this. So in some way, in the world we will consider in which we will reduce interaction to some type of game or space of games, which is a specific way, of course, to see interaction. You could see it in very different terms. Defining a situation, as Goffman would say, is the fundamental activity we have in interaction, is really defining which kind of game each agent is thinking he's playing, given a same material background of a whole space of games. That's the fundamental background. So to summarize, just to be sure, imagine that you have a broader space of, let's call them native or true or real interaction structures in the world, but agents limit very much their conception of this space to a few situations, which are the result of the fact that they capture some dimension of interaction, not all of them. They categorize them, they discretize them, and then they combine these discrete categories in something like a situation. That's the way we operationalize it. Of course, there can be richer notional frame, but this is enough to deal with basic game situations fundamentally.
How important is the assumption that we form a partition of the projected space? I mean, does it make any sense to think about a notion of overlapping cells, or a notion where not the entire space is covered by these cells?
Yeah, I must say partitioning is here probably a kind of convenience to start with. But there are very interesting questions that arise. First of all, as we know, categories are never very precise. So there's an interest problem that they overlap. An even more interesting question would be, we are not aware of all the state space, right? So it's not a partition because there are holes there that you don't cover in a way. We want to address these issues, but for time and laziness, we are still working to start with the convenient idea of partitions. I'm completely agreeing with you. There's for economists, there's also a sort of possible source of equivocation. Talking about partitions immediately calls in mind information partitions and brings back to a more traditional word probably of knowledge representation in games. But it's just a convenience to begin with. As you will see, it wouldn't be very hard to extend it, for example, to some sort of distribution or whatever. But yeah, I agree with you. Partition is a convenience choice to start with. We hope to remove it as we go on, but that's how we start. Other things that you think should be clarified? Okay.
Maybe another question.
Yeah, please.
So you're talking about the projection into a smaller space.
Yeah.
This means selecting among the features some relevant one, kind of feature selection, or maybe a combination of features. Because one thing is to select say 3 features out of 10, and then just focus on them. Another thing is to project a 10-dimensional space into a 3-dimensional space, which you can get by combining somehow.
No.
Talk about projection.
Projection is literally taking a larger space and projecting on a smaller one. So you don't how could I say, ignore dimension, you project them on a smaller space. That's the assumption, yes. Yeah, absolutely. Okay.
The question is that reality is always unpredictable, and your picture there just tells that you can't really tell what the situation is. Yeah,
but anybody guesses it in some way.
Then you can guess it, but then if you want to predict it, then it's going to be very hard. Okay, that's it. Just think of that situation.
Yeah.
That's just a word for some real or fake situation. And that would be very difficult to characterize. Very hard.
Yeah, that's what frames do for you in a culture. They help you to understand what's going on in many cases, right? Yeah. That's exactly what frames do. If you are in a medical, I've been recently interested in medicine, for example, in migration medicine. Clearly, your frame to deal as a doctor or as a Westerner with the problem of illness and how to deal with it gives you some precise notion of what is a body, who's the owner of the body, what is a symptom, what is a cause, right? But if you talk to a person that come from different cultures, you might get a very different notion to whom does your body belong, for example, what is illness, what's cause versus other things, and you can get a very interesting situation. But any culture tends to have a pretty well-stable set of frames that help to define, I think, situations. But the question is, of course, what happens when people, the interesting one at the end will be when people have different frames, of course. Honestly, one of the motivating reasons for me to get into this kind of research was answering to the question why people don't laugh at my jokes, right? And that's exactly, I think, because sometimes we have a different frame, but okay, that's another story. Sorry. Yeah.
It reminded me about the variation in
It reminds me something about variation game theory, the last one, in which the player can choose among different set of possible games, and it learns, thinking whatever is the best game to play.
Yeah, here you don't choose among games. There's just one real game. You choose among different representation. Actually, you don't choose in our initial case because you inherit it from your culture. So the interesting question is, what if you have a whole repertoire of frames for the same, for example, situation, how you choose or play strategically with it to persuade or to cheat or whatever. But what you will see today is more primitive. Imagine that you are born in a culture and you have a frame. What's the implication of it? But yes, of course, you could have. And strategic manipulation of frame, which is much studied in communication under the heading of framing, is really choosing or trying to suggest frames to others. Yeah.
Different perspectives, you can see this as a kind of game into frame. So it means from a different frame because they're from a different, let's say,
yeah.
culture, a different one, and we want to find a kind of equilibrium between the two.
Well, the game is, of course, between two players. There might be a game between frames in a sort of evolutionary perspective. So you could ask which frame could prevail, for example, in the long run or things like that. That's another question, of course, which is very interesting. Are some frames particularly resilient, or other can be easily invaded by other frames? That's a question, of course, we have asked, actually, and it suggests very interesting questions, which has to do which cultures are more or less resilient, for example. Like that. Yeah. Okay, thanks a lot. I hope the background of this is clear enough. You see its limitation. It's very stage one in our research. We have a few years to go on, and I will tell you more about the overall program, but that's it. Actually, that's the main research agenda we have for the next time. We started really dealing with two simple questions, right? The first one is, if you have different cultures, do you have different equilibria, and what do they tell you, right? The second one is, what happens if you try to change a culture because of some external event or some leadership or whatever that changes things? What are the trade-offs arising in particular? The second step, I will not be talking of it, although it's the most interesting one, of course, but we don't have still much results about it, is when two different cultures meet, what happens? And that's a really interesting problem for the European project, of course. What happens when two different cultures meet? The third problem is more dynamic in a way, is how you adjust to surprise when you meet another frame and how you deal with misunderstanding. That's the creative misunderstanding issue, if you want. How do you negotiate your understanding with others and how it can be more or less productive? And finally, what you probably implicitly ask is, if I have multiple frames, I might try to manipulate them strategically, right? And try to, for example, that's communication and persuasion as a problem. That's the kind of agenda. Unfortunately, I would say, because it's the most boring part, but that's where we have results, so we'll focus on this. But I hope it will give you a sense of the tools we are trying to develop. That's the fundamental idea. Although it's the least exciting, probably, question, still it requires some initial effort. Okay. But so usually when we present this, most questions come here, and it's a big effort to say yes, but sorry, we are still there. And so preventively, let me say preemptively, yes, sorry, we are mostly there, right? Although we have idea. Okay, here's where my work with Bob, not Bib, but there's Edna. I cannot resist making typos. You know, it's too strong. I love very much. There was a very famous experimental poet, Sanguinetti, that used to say, "I never correct proofs because printing mistakes are a great source of poetry." So take it like that, right? So the first important thing in the simple kind of modeling situation I want to explore with you is that, and it's not necessarily the most used, is that we consider a whole space of games instead of a single game. That's the idea. Which is the sort of true interaction landscape in which people live, the different combination of states of the world can produce different games and so on, where there are both opportunities of cooperation and temptation of conflict combined in different mixtures. And there are many ways to generate such spaces. We took a very simple one, starting from a simple idea that whenever you take maybe abuse kind of prisoner's dilemma situation, which in a way compounds opportunities for cooperation with temptation to defect, it can be always reduced to a combination of two other games, a common interest one, and a zero-sum game.
You mean a complex combination of
Yeah.
technical...
Yeah, absolutely. Yeah. You can always get a prisoner dilemma as a combination of a zero-sum game and a common interest one, where a common interest game is, of course, one like in which you have a same, right, converging interest where you have aligned payoff, let's say. In the other one, you have, of course, completely misaligned ones, and a combination of the two produces it. So if you take basically those as sort of corner paradigms and you combine them in different ways, you get a large space, a potentially infinite space, of course, of different interaction situations. That's the space in which our agents live, which is rich because it has all kind of possible type of basic interaction contained in it. So that's the first simple idea. So consider it either as a combination or as a lottery. You might basically, with some probability in such point, get a zero-sum or a common interest game. It's the same idea. Okay, so that's the world in which our agents live. You can generalize the numeric example by using some more abstract formulation in terms of payoffs, and it turns out that actually there's a very interesting and nice property which in this kind of world, this combination of zero-sum games and common interest game, you always have in each point of this world that an agent has always a dominant strategy, which simplifies a lot, of course, strategic reasoning and makes it easier to analyze this kind of space. So this is a little artifact that makes life easier in a way. And actually you can show that basically you have a dominant strategy if and only if, right, pi, which is equal to A, which as you can see is the payoff of the common interest game, right, divided A plus Z, where Z is the payoff that you get in a zero-sum game, are different from 1 minus P. When they are equal, you are indifferent, basically, between playing the two basic strategies, right? Okay, so that's the sort of simple proposition. You can actually show that given this, using dominant strategy, the expected payoff is 1/3. We will use it as a kind of benchmark for that in this space, right? If you take the integral over the space, the expected payoff is 1/3. Now, the first thing we do is constructing a simplified version of the game. The game by itself has three fundamental dimensions, right? P, A, and Z, but you can actually reduce it to a space in which you only have two dimensions in this case, which are P and pi. And you remember we saw pi last time. Pi is just the ratio between, oops, I'm getting lost with this silly thing. Okay. Pi is defined as A over A plus Z, which means that what you lose in this case is information about the absolute value of a payoff, but not the relative values of payoff, which basically means fundamentally that in this kind of space, you ignore the absolute size of things. That's the only information you lose, but you still preserve, that's important, dominance. So it's a projection in this case that is good enough to preserve dominance properties for each game, although you don't know what's the absolute value of payoff, okay? It doesn't make a difference from a dominance point of view, it might make a difference from other points of view. And you could imagine other type of projections which produce different things. There are many other ones. If you want later, we can see some alternative way to project this space on different type of frames, and this produces, of course, very different interpretation. But basically, this is the projection we work with, which is very handy because it preserves dominance. Okay, that's very important. So what is dominant under the full representation is still dominant under this simplified one. Okay, so that's the kind of single example we explore. There could be other ones, and you could explore other projections, of course. That's an important point. Some of them still preserve dominance, some don't. The second idea was beyond projection, if you remember, categorization. So we assume, to make life simpler, that actually every player and every frame, as we will see, imply that each of those two dimensions gets categorized, get discretized in two, let's say, high and low, right, categories. And this categorization is defined by thresholds, let's call them p hat and pi hat, which are, of course, parameters we will modify to see what happens. So already you start seeing that if you say that each dimension is categorized and given some threshold, like high probability, low probability of finding, in this case, a cooperative situation, right? Basically a common interest game. Pi is this ratio of payoffs. What you get is that you subdivide, right? You can partition the space in 4 cells, fundamentally, which are our 4 situations. So this is a simple instance of how you could create a frame. What is a frame in this case is, first, you project on P and pi, in this case. Second, you categorize by using P hat, pi hat, the thresholds, and this defines 4 cells. Each cell, that's the assumption in this idea, is seen as a single game. So to each cell, people have in mind a corresponding game, whose payoffs are basically the combination of the payoff within the space, the cell. So the idea is that people actually have in their mind 4 games, not an infinity of games. Each one of them is a kind of situation or typical situation they have. Okay, that's the simple way to imagine how you could produce a little model of a frame. It's a very simplified one, it's an extreme one, but it's showing the logic through which you could go and have selection of dimension, categorization situations. Okay, that's the idea. Okay, so 4 situations are defined at the end by this threshold pair in this case, and each threshold pair corresponds to a frame. And a strategy prescribes an action for each cell. So in this case, individuals don't conceive a strategy for each point, but only for each cell, because they think only about what the situation is this, which kind of game am I playing, basically, and once I know which kind of game I'm playing, I decide my strategy according to that, okay? Which is what happens all the time. You don't make fine distinction between different situations. You know what to do in such a situation, and you do it, okay? That's the implied idea. So these are, yeah.
This reminds me of multiplayer games, which have a very long tradition in game theory. They don't have just a pairs matrix, but several pairs matrices. And there's a long tradition in game theory dealing with this notion, trying to generalize notion to the game. Is it somehow related to this notion of multiplayer game?
Well, yes and no. Here, what you have is that each game has a single-dimensional, well, 2-dimensional or payoff. My payoff and your payoff, actually, right? There's nothing else than that. So you don't have projections over payoffs, for example. You couldn't consider that. Here, we are only considering the fact that you have a space of possible structures of interaction. That's what you work upon. Of course, you might conceive structure where you have layers of or multiple dimensions over payoffs and imagine projections over that. That's something we play with. That's not what we do here, because we want to have one thing, which is what is the situation, but then each situation has a pair of payoff, right? And that's it. So, okay, from frames to behavior, which is the interesting thing. So what happens in this case, right? What's the story here? It's interesting that given this kind of extreme simplification, too extreme, but of course a model is always too extreme, what you produce is a situation where you have 2 basic rules of behavior, right? And that's a very interesting thing you can show. So what happens is that there are 2 basic rules. One, and they depend on where the intersection of those 2 lines are, right? If they are above the diagonal, you have fundamentally the idea that you play high, so you cooperate fundamentally in, we call it the OR rule, either when you are above one of the 2 thresholds. That's why it's the OR rule. It's enough to be above one of the 2 thresholds to cooperate. So you cooperate in 3 situations out of 4. It's always what you should do. Okay, so the first thing that we show, if you want the results, but I skip over the proof of it, but the basic idea is that whenever this point is above the diagonal, players will cooperate in these 3 situations. They will apply sort of OR behavior rule. On the other side, when this is below the diagonal, sorry, I should use this because otherwise I cover the screen, you follow an AND rule. So you have a more strict rule of behavior. You cooperate only when both thresholds are passed. Okay? So these are the 2 fundamental sort of rules of behavior that apply given a frame.
So what happens if on the diagonal?
The diagonal is a little bit trouble because, as I told you, this is a case where you're indifferent between playing both. So this is, and we will see also the payoffs on diagonal have a funny behavior. So we'll get back to diagonal later because it really is a point where strange things happen. But with the exception of diagonal, right, what you get is it's either or and. Sorry for the pun, I didn't want to do it. And fundamentally, that's the simple idea, right? So the or, respectively, and rule is dominant for pi hat plus p hat plus pi hat larger than 1 or less than 1, so below or above the diagonal. So there's a large number of possible frames, but there are only two big rules of behavior that emerge in this description of this. It will be important later, as we will see, because this creates some strange and fun effect. Okay, so that's how frames relate to behavior. Now what we try to do is work, unfortunately, that I told you is the most boring part, with the idea there's a shared frame among the players. So we don't play with different players and different frames, but you live in a country where everybody has or you live in an organization where everybody has the same frame. But there can be different countries or different organizations where different frames are present. What's the implication for the system, right? In this case, for the country or the organization. So basically, same rule, right, of behavior we have seen with different thresholds. Each frame defines those things. And within a culture, the interesting thing is that as long as every player frames the game in the same way, he will be behaving according to the same and or rule, right? Which means that although you have a very limited view of the game, you have no surprise. There's a sort of mutual understanding. The behavior of the other is entirely predictable. You do exactly what you expect to do. He also behaves according to what you perceive as dominant behavior. So fundamentally, you are in a sort of equilibrium state, although, that's a fundamental thing, you don't know about what might happen with other frames or whatsoever, and you don't know what happens if you look game by game, because you have this very aggregate and simplified view of the things. So you have mutual understanding, although in a way you don't have, how could I say, you don't explore all possible, for example, frames, right? So it's a very broad view of equilibrium, if you want, much. A Nash equilibrium would be much more narrow. Even self-confirming equilibrium will be slightly narrower than that. So it's a kind of mutual understanding based on the fact that we are a little bit blind. We don't conceive other possible frames. And given that we have the same one, we have sort of mutually compatible behavior. We are never surprised by each other. We mutually understand in this very limited sense. Now, the first result, which is very nice, is that in this context, different frames will produce in general payoffs which are very different than the case in which a player would be aware of every single game in the space. Remember, the benchmark was if you are aware of every single game in the space, overall the space your expected payoff is 1/3, right? What happens if you have a frame? So you see only 4 very aggregate views of 4 situations, fundamentally. Okay, given your type of threshold, you have an interesting behavior. Just to make it visually easier, imagine that pi is equal to p. Pi hat is equal to p. So you take only, basically, parameters pi and p on the diagonal. This is just to simplify the representation. You can extend it to all the space, right? What happens is really nice. So this is the benchmark, right? This is the 1/3 payoff over all the space. Now, and this is the 1/2 that basically corresponds to the diagonal in which you are indifferent between the two strategies. What happens is that, of course, below 1/2 you have an end strategy, but as you can see, this is the kind of payoff that you get, right? So in blue you have, whenever you have payoffs exceeding the benchmark in which you know every state of the space, every single point, this is fog of cooperation, right? And this is fog of conflict. For these values of your frames, for these frames, you get a payoff which is below the benchmark constituted, but what would happen if you rationally and perfectly knowing everything could act, right? So the first interesting implication is that, in a way, within the lower triangle, right, what you have is an interesting phenomenon. You rarely get the payoff you would get if you knew everything, but you have both fog of cooperation and fog of conflict emerging from different frames. The second implication, which is nice if you go above, so in the above triangle, you have again the same thing. Here you have a NOR strategy, but you have fog of cooperation and a fog of conflict emerging with especially negative results in this case. So it's interesting that once you adopt frames, you can see that different cultures, in this case different shared frames, can produce very different outcomes, right? They can produce Vietnam or Ontario in some interesting sense, although this is not entirely the right comparison. Or they can produce the typical effect that you observe that in different cultures you have different levels of cooperation. For example, there's a lot of evidence comparing, for example, I know, China and the United States, rather than different castes, even in India and so on, and you get different levels of collaboration in different situations. So the first result, if you want, that once you adopt frames as a way to see the way people conceive the world, the apparent anomalies of fog of war and fog of cooperation become the rule in an interesting way. We permanently live in some kind of fog, and that produces payoff which are different from the one you might expect in the case of full knowledge of the space. Okay, that's the first, if you want, simple result. Should I stop here for a moment again before I go ahead? Is it clear? So that's the simple idea. And it's interesting that that you find it in both triangles. So you have both in the lower and the higher triangle, you get the same feature. And as you can see here, there is this huge right jump that we will discuss later because it has a lot of nice implications for understanding change. Clear enough? That's a very simple result, but we like it a lot. The other interesting thing is that, of course, it might be more natural, especially when you talk about culture, to move from single games to games played once to the idea there are repeated games, right? But in a space like this, there's not a proper repeated game situation because you never repeat the same game. You never stepped into the same game, right? That's a Heraclitean kind of game situation. So what you actually repeat is repeated interaction in a space. So each time you meet a different game, but from the same space. It's slightly different, of course, than a classical repeated game. So the analysis requires a little adaptation, which I think is fairly interesting because it suggests a few things. Oops, I always get the wrong thing. So what's the idea here, right? If you think of it, as we consider a space of game, first point, repetition happens on the game space, as I just said, right? Second point, which is very important, what you observe thus is just repeated situations, not repeated games. But the third thing that we will see in a moment, once you have the situation, frames and discount factors interact in very subtle and interesting ways. And we will see why in a moment. So the idea of repeated games, of course, that you have to take into account the cost of time, let's say, right? You have discount factor that determines, in many cases, the convenience or less to cooperate, given the fact that I might react to your defection by punishing you or whatever. And there are, well, you know the story. So we assume, as usual, that agents' preference conform to the classical discounted utility model, so it's fine. We are very conservative, nothing weird or funny about it. And they have the same discount factor delta, again, to make life easier. You could also differentiate it, but it does not change very much. And it's a standard model of a multi-stage game, and agents see only 4 stage games, not an infinity of stage games, because they have frames through their shared frame. Now, what is happening here is that it's very interesting. Of course, the trigger strategy is based on the idea that if you defect, I will defect, right, forever. Now, as you see the frame as made of both situations that you interpret as prisoner dilemma or games in which you rather cooperate, right? What is the implication of this? The implication is that, of course, you will retort only when you don't have a common interest situation. So you typically replicate to the defection in a situation in which it makes sense to defect. It makes no sense to defect in a coordination common interest game. So that means that according to how you split the word, you are likely to see more or less frequently an occasion to retort, to replicate to defection. So in a way, the shade of the future, how much future payoffs affect your current decision to defect or to cooperate, will depend also on how frequently you expect to interact in a prisoner's dilemma situation with the other one. which means that the shade of the future depends not only on delta, on the discount factor, but also on your frame that determines how frequently you expect to find a situation which is not one of common interest. So this changes a lot what happens in this kind of interaction, because it becomes frame sensitive again. So repeated behavior, again, repeated games in this situation depend not only on the discount factor, but also on the frame in a peculiar way, because this affects the way you discount the future, in a way. So fundamentally, this is the simple implication. The result is very nice, because again, as we will see, what you get is, again, a situation where you have a behavior which is dependent on the frame. So again, take, just to produce an illustration, a given delta, like 0.8. And again, x means that pi is equal to p, so we just study the behavior over the diagonal, although you can extend it over all the square, right? And here again, as you can see, what you obtain is that in some cases, in the and in the OR situation, right, you have one case in which you just depend, you behave as you would in a game, and in a non-repeated game, and others in which you actually cooperate always. And here again, you behave like in a non-repeated game fundamentally, and here you actually cooperate because you have a repeated game. So as you can see again, you can produce a variability of payoffs which depends in a crucial way from the frame. Not only, but if you compare that, I don't have the picture here, with the behavior in which you see every state, every possible game in the space, you get again fog of war, fog of conflict, and fog of cooperation. So sometimes you do better, sometimes you do worse than you might do if you had the full visibility of each state. So even if you shift from single game to repeated games, you still get the same type of results. They are sort of robust. And that's the second kind of result you have here. So this is just extending to a more proper context the earlier result. The last thing I would like to, how much time do I have actually? Because I easily lose control of it.
5 minutes, 10 minutes.
Oh, well, I hope I have more. Okay, I'll be quick. A clear temptation is, in this case, is to see what happens if, for some reason, right, since different frames imply different levels of payoff for a group, for a culture, for whatever it is, you might be tempted to ask what happens when you change a frame, because an external event changes, or maybe because some internal phenomenon, leadership or whatever, moves things. Imagine an organization with a new CEO that tried to restructure the corporate culture, for example, and to produce a new frame, right, and different levels of coordination. And here it's nice that even without going into dynamics, but just by making some sort of comparative statics, you can see some trade-offs which are implied in cultural change. So the obvious question would be, if there are frames that produce on average better outcomes, why don't you adopt those frames, right? Why don't you have someone, for example, an external leader coming, seeing the situation and pushing you in the right direction? Now, imagine, for example, that you have some external factor or some leader that changes the threshold, one threshold, for example, pi. So that you move the way the whole group conceives, or you try to move the way the whole group conceives the word, the way he splits the word. Now, what happens also in this case is quite interesting, because look again at what happens in terms of payoffs and frames, right? And imagine that you are, for example, here. Right? You can see there are two very different types of change. One, you might call it some sort of incremental change. You try to move upwards here, right? So you move to the left, you try to push in this direction. The advantage is that, as you can see, this is disrupting very little things, because you are still in the same region of behavior. So people don't have to change behavioral rules. They only have to adjust their perception of in which situation you are, but it doesn't change the way you apply your basic behavioral rule. And increases in payoff are actually, right, absolutely corresponding to the idea of an incremental thing. On the other side, and that's an important point, you might be tempted to go here, because here payoffs are much higher. But at the same time, here you have to change completely behavioral strategies or patterns of behavior, behavior rule. You have to move from the and to the or. Now, this poses a couple of interesting problems with change. The first one is, first, imagine that you take a direction, but you don't know exactly how much people will change, right? Risk is that if you don't go enough to the right, for example, what you get is not an improvement, but a decrease in payoff. So if there is uncertainty about the effect of change, this becomes a much more risky kind of change. The second one, which is even more interesting, is that imagine there's some delay between the fact that you make people adjust the way they classify the word and the fact that they have to relearn about the payoffs corresponding to this new view of the word, so the rule of behavior might adapt with some sluggishness. And there might be some inertia of some type in behavior. This creates a situation in which basically once you change, you have to get worse to get better, which implies that in the short run, change will produce a deterioration in the performance of the group, and only in the long run you will get the fruits of change, which again implies that it very much depends. For example, if you have a leader trying to change an organization, which might be a typical case, if the leader cannot wait enough, right, for the change to happen, he will be basically wiped off. So you can, in a way, try to analyze some of the trade-offs that you have when you are dealing with cultural change by looking at just simple this kind of basic thing. And the idea of being able to reproduce not only the two fogs, but the big difference that you have between incremental and disruptive change is what we find also appealing despite the extreme poverty, if you want, of collapsing frames just to the case of everybody shares the same frame. Okay, this is the other type of results. Let me make again a little stop here if you have question or remarks. That's the kind of results you get from this very quick analysis.
These ideas could be, I think to my mind, this very well-known notion of paradigm shift in science.
Yeah.
And one of the points made was that when we have a paradigm shift, we actually see the world in a completely different way. So I was wondering whether we can try and apply the framework for understanding how science progresses, so using the very idea of the paradigm shift in Thomas Kuhn's framework.
Yeah, here you have something, I'm not sure it applies to science because it's a pretty different game, if you wish, right? But certainly if you think a sort of paradigm change in groups or societies, that's what you observe in many situations. So you have cases in which you change completely the rules of behavior, right? Yeah. And that's what you have here. And here the predictions are two. First, it's extremely risky because in many cases it might be not enough to reach a region that you need to reach to get an improvement in payoff. So if you are here, moving here is not taken for granted. Second, if everybody doesn't move at the same pace, of course you have a lot of interesting coordination troubles which impose a big cost. But third, if there's a delay in behaviors, they follow perception with some delay, then you really have this phenomenon of very serious deterioration of the performance of the group, which is also something which relates to paradigm change, as you know, which is initially a paradigm change provokes a huge loss of knowledge that you can only recover later. Although I think this is a very forceful analogy, but yeah, I would say it's interesting. Any paradigmatic change produces loss initially, right? Here it's a loss in payoff, by the way, not in terms of knowledge, and I wouldn't force too much the analogy, to be honest, but yeah. But anyway, yeah, you're right. This is a kind of paradigmatic change. You have to change completely the way the rules you apply to situations, not only how you classify the word, but also the rules that apply to this classification. Here, you don't need to change the rules. You still preserve your kind of patterns of behavior, if you wish.
It would be the same thing that happens when we have a full solution in the group conflict that we jump from a phase to another.
Full solutions?
The full solution when you're looking for mathematics.
Oh, we're talking about mathematics. The first solution is a combination of two different. No, I don't think it's the same thing. The first solution somehow combines two or more different solutions. In some sense, it combines many one in a single solution.
No,
but here we have a kind of
the problem of the cherry. Which you balance
you might
possible solutions.
I don't get the problem. Anyway, we try to avoid multiple equilibria in any possible way, as you see. So we choose a situation where we have dominance and so on, just to avoid the complication arising from it. That's why we actually did it. And so we can keep the analysis simple enough without introducing other problems, how you select equilibria or whatever, which introduces further complications. Okay, that's basically, and then you have implication about which type of change, how does it relate to things, that what I just discussed. Sorry, this is already what I said. Okay, that's basically the modeling idea, and as you can see, it's really a first step. It might be, as I told you, maybe the least exciting. It's very basic, but at least it shows you that you can reason through those frames and start establishing some results. Of course, the next step is looking into differences of frames, into the relative resilience of frames, are they invadable or not, what kind of dynamics can you trigger, and so on. But of this, next year I hope I'll have something to tell. At the moment, there's nothing really done, although we have some first interesting results, but they are still very vague and so on. The second aspect I wanted to, and I will spend my last 2 minutes, right, on that, is just to recall you the type of historical case study we have in mind, and I hope now we can start seeing the connection between the two, although they are still loose, I understand. And it is the second part of the project we are trying to manage, which is the study of anti-Semitism in France. And here also Simon Levi-Sullam, a historian, is involved. Here the idea is really to see how from language you can extract frames, and from this you can understand some dynamics in social movements. That's the fundamental thing we are trying to address. As I told you, what we are interested in is in tracing the emergent frame of anti-Semitism over 2 centuries. France has been the cradle of anti-Semitism, actually, even before Germany, under many respects. So it's extremely interesting to look at the evolution of this kind of frames through history. And of course, words and terms of phrase can be sort of cultural objects that you can use to trace this evolution, right? And what we are interested in is, by the way, trying to look not just at the text, but at who is saying what. So try to find a way to combine the analysis of the text with the analysis of the sources of the text, because it's fundamentally important to know who's saying what in this case. And in particular, how the sort of social networks of different groups and movements, I will describe in a short moment some of them, are interacting with the type of language that you use and the type of frame which is implied by the language. So the idea is to construct, if you want, not just one space in which things happen, but to understand how these spaces over time diverge and they create different areas of discourse over history. The sources I told you are from the Gallica project. Just by looking to the Juif keyword, we get 7,000 documents, books, pamphlets, bulletins, even songs. It's a very interesting, diverse source of things. And we are looking for other sources, right? So what is interesting for us is really the historical emergence of the anti-Semitic frame, the idea to perform this kind of analysis over a really large span of time, right? And in particular, how, on one side, anti-Semitism is the result of the convergence of very different domains of discourse. At the beginning, you had, for example, discourse about deicide in the religious domain, about usury in the economic domain, about conspiration in the political domain, about betrayal, and so on, right? And all of these were performed in different words. For example, the deicide was very much typical of the word of right Catholicism in France, but usury, associated to Judaism, was typical of the emergent proto-socialism in France, right? And at some point, these different streams, these different words of discourse find a way to converge and to coalesce in a single view of what is anti-Semitism, right? So this is, first point is how different domains of discourse and different frames in a way converge and merge is the first object of a historical analysis we're looking into. The second one is that this is also changing key domains, right? So there's a change in the dimensions you select. For example, in the second half of the 19th century, there's a dramatic shift from religion, anti-Judaism, to race, anti-Semitism. I never knew before I actually started this project that anti-Semitism is a recent term that comes in the second half of the 19th century, right? And it brings a dramatic change from religion to race as the object of discourse, with the emergence of proper modern anti-Semitism, which is the sort of synthesis of different streams, right? And then you can look at specific episodes where two cultures clash, two frames clash, And the affaire Dreyfus is, for example, the classical example where France got split in two around the case about anti-Semitism. We want to study it as a kind of polarization in opinions produced by this divergence of representation of what it means to be Jewish, basically, in the 19th century France. And so you have questions like how do different anti-Semitism interact over time and interact with evolution of semantic domains. How does evolution of debates interact with sources, media, for example? The emergence of different media can trigger different type of debates. How do words shift across the context in time, and how do words follow, but also in some cases predict historical events, right? Because a lot of these transformations interact with very precise historical things, sometimes anticipating them. You can predict actually the Dreyfus affair, and in many respects, looking at the mounting wave of association of Judaism and treason. And on the other side, you can see how another phenomenon, the association of Judaism and usury, follows a financial crisis in the 70s, right? So you can really try to reconstruct in the long run the complex interaction of historical events, social movements, words and concepts, and, if you wish, frames, in the sense that we want to extract from this data the fundamental domains into which basically the different players define the object of their interaction. Okay. That's it. That's, I hope, just a call for ideas and common interest. I think there's a lot to do in this area. And what we hope to do is to be able to capture both the empirical side, but the modeling one, to have some game theory that can explain phenomena you can extract from here and so on, right? So that's the sort of ideal convergence we are looking into this project. Okay, thanks. That's all I had to say.